Data that provides us everything. Suppose you are there, I'll take a very simple example. You are there, a lawyer is there in the court, okay, and they say that, okay, I know this person has done the crime or this person has not done the crime, okay. Then how can they prove it? They need evidence, they need data. So that is what they need, the facts. Okay, so that is what data comes from. That is where data evolves from. It evolves from us. It evolves from every entity that is there in our surroundings. Now you'll say, okay, what is an entity? I don't know what's an entity. Okay, so entity is, it's an object. The object can be your pen. Object can be you yourself. Object can be any object in the world. Okay, and every object, it has certain, you can say, sort of they have the features, they have details. Okay, so these details, they can be put into the data. Okay, what is, suppose you'll take a simple example of a coin. Okay, so coin is, it's a 1 rupee coin. Okay, so we'll say that how many coins do you have? I'll say I have 1 rupee coin, these many. I'll say 2 rupees coin, these many. Then I have the facts about how many coins do I have. Okay, now there is a system that tells us that how the data can be analyzed, how the data can be differentiated, because we cannot compare a coin with a note. So there should be a differentiation. Okay, there should be somewhere that defines the data that, okay, this entity is different from this entity. So whenever we talk about a relation, whenever we talk about there is a differentiation, there is a similarity, then there comes the picture of relational data. So the relational data means there is some sort of relation. There may not be a relation. That's also a relation. Can you say that? Yes, that's a relation also. That they are not relative. Okay, so they are very different. Okay, so this is where data, entity, everything comes around. Yes, so we were talking about database. Okay, what is a database then? Database is a collection of data that can be into a form of columns and rows. That's a tabular format. Okay. We have some of the databases as well where we may not follow the tabular format, like NoSQL data, or somewhere like some of the databases where we use the object-oriented databases. So there but we have to follow a structure. When we talk about database, when we talk about file system, we might not have to follow a structure. So how do you find the details of a data which is there in your database? How do you find a detail like, okay, what is the name of this person whose name is starting with S? Okay, how do you find this? So you have a tool that is called query. You query the database and you get the result, and that is how you find the details of any sort of information that is there in your database. This entity. So you will have the rows, you will have the columns. The columns will have their headers. The headers will have the details about what type of detail is there inside the database. The column name, you say, okay, the column name is name, so it signifies, okay, this is the name of the person. The salary, okay, this is the salary of the person. The age, okay, this is age of the person. So you will have these columns kept like this, column names, name, age, salary kind of thing, and there will be so many entries for that specific column, and those are called rows. And using these combinations, you will find a database. So basically, when you collect a row and column, then you form a table, and we collect so many tables. They'll start with what are the types of databases. Okay, so there are so many types of databases, like centralized database, distributed database, you can say relational database or cloud databases. So there are various, if you talk about minute differentiation about types of databases, then there are so many. But I want a centralized database where your data, it is kept somewhere on the server. Okay, in the server it is kept, and so many users try to query the data from that server where the database is put. and that is called centralized database. So it's a kind of master database, you can say, where the whole data is kept, and there are so many users who try to copy the data, or maybe who try to select the data, who try to retrieve so many information from the data, and that's a centralized. So the next one we'll come towards is the distributed databases. So the distributed in the sense, the databases can be distributed over so many areas. Suppose one of the database is in one of the location, that is maybe you can say Urbana, somewhere it is in America, one of the database it's in India, one of the databases is in South Africa, another one is somewhere else on all over the globe, and the users will be also so many who will try to gather the data from all those databases. So that's a distributed database. Now coming towards what's a relational. Relational in the sense that you will have the data, the tables, okay, collection of the tables, where one table will be having somewhere a relation with the another table. Suppose in one table my name is there, Mukund, and my age is there, my salary slip is there, and so many details are there. So it's a one table, and my date of birth is also mentioned. Now if we go talk about the second table, in the second table there is somewhere it's mentioned that okay, what is the work location of Mukund, okay, what Mukund likes, okay, are some of the, so one table is there which has some other features about Mukund, another table is there which has some other features of Mukund. So these are relational tables, and this is where we call it as the relational databases, where one database will have certain relation with the another database, one table will have certain relation with the other table, and when you try to query, then you will, everything is not stored in one table, some tables have some of the features. Last one is the cloud database, where everything, all the data, it is put over a cloud. When you talk about cloud, then I'll give you a brief intro about what is the cloud. Is that the data, it is stored somewhere that is not known to you. That is stored on a remote server. The server can be anywhere in the world, and you try to access it online. When that server is online, you try to access it. Maybe if the server is not online, you might not be able to access it, and that is called the cloud databases. We will talk about the client server architecture. So the server is a place where we can store the data. We can store our database. We can store all the information that is meaningful to the users or to the clients. So what is a client? Client is someone who tries to get the information from the data. And the server is where the actual data is stored and from which the client tries to pull the data. So server is the source, and the client, you can say, it's one of the hops or the destinations where the data floats through, and this is the whole client server architecture. Okay, so right now we will talk about a difference between a file system and a database. So a file system is there where you can read and write any amount of data, any form of data onto the file system. You will store the data, and that is raw data that is generated from somewhere, and you will just keep it. The data may be redundant. Redundant means data may be duplicate. There could be sort of data that is okay, this is a picture of Mukund that was taken somewhere else. This is a picture of the same Mukund that was taken somewhere else. Okay, so this defines that okay, the entity is the same, but it's a duplicate entity. It's an entry of the entity that is duplicate. The data may be less secured. There may not be so much of security, that how the data is how much your data is secured on the drive data, and it's very much sensitive when you talk about the security of the data, and their file system somewhere fails, and that is why we evolve with the databases. So when we talk about database, then it's in structured format. You have rows, different rows, and you have columns. So those columns specify the type of data that is there in the object. So object or entity, that object is taken as, or it is denoted as, table inside the database. So a table, it has the name, it has the ID, it has the salary, it has the age, it has so many details, And all these can be taken as a feature when we compare a table with an object. So a table named Mukund, it has all the features about Mukund. An object who is Mukund itself, and he is having all the features that is there defined in the table. So the object features are defined in the table in a structured format. It has everything that is there, all the details about the object, and it has the data types as well. So suppose name, okay, so name, can the name be an integer? Can the name be a number? No, a name can be only and only a character type, okay. The age, it cannot be a character, it should be an integer, it should be a number type, okay. In the same way, maybe when you talk about ID, then it can have a character as well as a number. So when we talk about character, it consists of everything, a number as well as alphabets, as well as it may have some special characters as well. So it consists of all the things. Inside the database, data can be modified. You can modify the data by getting inside the table, delete that specific entry, or you can update that specific entry, and that's a very beauty, it's a beauty of the data. But in the database you can modify, you can also query whatever you want, you can query the exact result. Okay, I want to understand that out of these employees, how many number of employees are having name starting with S. I will form a query, I will get the exact number of employees.